3 years does go fast. It's amazing. So let's really get into this this briefing. In doing so, I just wanted to baseline where we were in 2012, 2013, and remind folks how bad it was in 2013 with respect to the uncertainties related to the sequestration that really weren't ended until beyond the first quarter of 14. So with that uncertainty and actually having the prospects of the budgets that we would have been living with if we in fact got sequestered, we were actually executing the worst case scenario. So just remind folks that I am getting some feedback here. Just maybe with this. The operational computer itself was under-resourced. The model upgrades and implementations were lagging. And for better or for worse, we were getting measured more by that than anything else. All the blogs written about the modeling and the computing. Dissemination systems were not sustainable during this November 17th, 2013 outbreak. And it was really the basta, but in Italian, when you say basta, people are continually trying to feed you. And they know you mean enough, okay? But to have 3 different regions go out for 3 different reasons that took almost 24 hours to diagnose and fix during a severe weather outbreak was enough. The travel was slashed, including local travel for operational support. The training was slashed. The conference attendance was minimized. Facilities in disrepair. The C-STAR, our ability to engage the outside research community was basically on life support. Vacancies were definitely worsened by the sequestration threat, and we're still trying to get out of that hole. And components of the National Weather Service field structure not working well together, inconsistent products and services. And this inconsistency was what we were hearing the loudest about from an emergency management community that really was attempting to use our products and services more than ever before for actually saving lives and mitigating property loss. So this is a way of sort of measuring where we were. I think people have seen this building a weather-ready nation. The fact is that it's an amazing strategic outcome that is resonating across the entire enterprise, the weather, water, climate enterprise, and has certainly engaged the users of the information from that enterprise to work to save lives. And we now, this Weather Ready Nation Ambassadors initiative has over 2,600 registered ambassadors, and it's really become a force multiplier, whether we're doing safety campaigns, whether we're alerting to the upcoming extreme event. In cases now, I'll show you over a week in advance. Okay, just keep that in mind for those of us who've been around for a long time. Over a week in advance. It's really been amazing. So we're working obviously to produce better forecasts and warnings. The consistency aspect is something that we're really focused on, and to provide actionable environmental intelligence now to work towards key decision points for people who are out there on the ground making decisions with respect to people's lives and livelihood. So we need to address this last mile that connects forecast to critical national, state, and local decisions. We're providing impact-based decision support services. In this review process we're going through with our operational workforce analysis, we've learned that our workforce has really embraced this, and that our users are actually using it. And for those McKinsey group who actually did a review said this was novel. How many times have they reviewed a federal agency that says, hey, here's all the things we're producing for our users, and then they look up to the users, and it's on a shelf somewhere, right? So it was really emphasized how important this IDSS is becoming. And we're working to establish these multiple and reliable dissemination pathways and work with partners, and including embedding now with the emergency operations centers. Remember, they're making decisions 2, 3, 4, 5 days in advance of an extreme event, entirely based on forecasts. Okay, so this is really become an important part of us moving forward. When we talk about evolving the National Weather Service, we've been asked, what does that mean, and what does IDSS mean? So we're working from just producing the forecast and warnings to connecting those forecasts and warnings with partner decision-making. And that's a big deal. So 10 years ago, 15 years ago, even as we were generating the strategic plan in the mid part of the last decade, there were many who really wanted our job to end with just doing the forecast and warnings. And then 2011 happened with that severe weather season. And we realized that whether it's the watch or the warnings, it's how you're partnering with people that's going to make a difference, as hundreds of people lost their lives with very good forecasts, very good warnings. Okay? So we still have a lot of work to do in this last mile. And what we're learning, I've done a number of trips out to the field now, and when I'm out there, I meet with the state or the local emergency operations centers. It's not what's happening during the event, but it's the practice. A year before, 6 months before, a month before, the continuous interaction with our partners is something that's key to the successes that we're seeing today. And embedding and making sure that our products actually relate to their key decision points is what's the basis for IDSS. This chart is one of the drivers for how we've moved forward in building a weather-ready nation. You notice in 14 and 15 is heavily weighted towards getting the internal structure developed in such a way that it would allow us to make our budget process more relevant to the forecast process, more transparent to people outside the Weather Service, people inside the Weather Service. And basically, you see the red check marks there. We were very successful. April 1st of last year was the bellwether mark for having our budget structure and our headquarters structure formally implemented and working together. It started April 1st of last year. So we're still within the first year. The thing I want to highlight here, and what's at the top of the list, is for this year is to complete the operational workforce analysis with recommendations. And as you see, we go to 17, start to test and evaluate those recommendations, and then implement the operational workforce analysis recommendations over a 5-year period, 18 through 23. It's a slow process. You have to assess each step of the way. For those who were around during the modernization, know a phrase with no degradation in services. Certainly, we use that as a baseline. But we just can't flip light switches here. So there's a whole process that has to be we have to engage with. And you'll see other highlights that come in. We can shut off this thing, right? Or maybe I need to shut this one off and just stand there. Okay. So the main thing here that you see on 16 that's already been accomplished in the first quarter was the supercomputing capacity has been increased, and the Cray computer is now declared operational, and we're in a process of moving some fairly significant modeling systems over to that computer. I want to remind folks about the structure, the planning and budget structure that increases transparency and enhances the service delivery. The top 4 portfolio really reflect the forecast process, observations. All forecasts start with observations. We now have a focus on this. It's not spread through all the other PPAs that you'd be in competition with. So now we have a solidified portfolio in which all the observation decisions can be made. The central processing, which includes the central computer all the way to the AWIPS ATAP systems, analyze, forecast, support, includes all the forecast offices. This fully integrated field structure, which is a key for providing consistent products and services. And I'll just indicate that the operational workforce analysis is really focused on that particular aspect. The dissemination portfolio, it's showtime for dissemination. We have to have a solidified system. We have to be ready, for example, GOES-R, JPSS, and all the modeling data that will be coming at us. So we'll go a little more detail on that. Science and technology integration is to fix, enhance our forecast process. So that's a separate portfolio. And in the facilities, you have to house the forecast process. And to tell you the truth, up front, it's the facilities that are right now the weakest link. We have a lot of problems with the facilities. Think about those 20 years ago, building all those buildings at the same time, putting in the HVAC units at the same time, putting in the ups at the same time. So now we've got people who rewards their investments. The last things they want to do is put money into ups and HVAC, right, as an example. We've got a lot of work to do there. We also have, so that's a negative aspect that one has to deal with. We also have increasing opportunities to co-locate our forecast offices with either research folks or the folks who are at this IDSS where we practice. So there's a growing interest in us co-locating, for example, with state emergency operations centers. Okay, and it's something that we're looking at very seriously. That would all be handled in the facilities portfolio. The headquarters organization reflects that structure across the bottom, so we have a one-to-one relationship. You see 6 blue boxes there on the bottom that map directly into each one of those portfolios. And you see the leaders now, these are all no active here at this point. Andy, MG, Lucano, Dave Michaud, Joe Pica, Deirdre Drummond. We have the Office of Planning, Programming for Service Delivery. Kevin Cooley came back to us. For those who remember Kevin, first at NSEP and NCO, and then as we know, orchestrated the OCIO for the Pentagon for 10 years. He's back with us. And Office of Chief Operating Officers under John Murphy. So, and he has the analyzed forecast support and in the field that delivers my vision. So we have a focal point on the right-hand side that from budget planning to mission execution and the longer-term planning and ensuring that all those other portfolios are threaded together to keep the mission. Kevin Werner, who is here in the back, is just coming to the Office of Organizational Excellence. And John Rogren is acting under the Office of Chief Operating Officer, so we have training elevated. And let's see a couple other changes here. Tom Graziano is acting on the National Water Center. Don Klein moved on to the USGS. And Carmen Scott is acting on the last school region. That's Amy DeVera is also moved on to the USGS. So we've become sort of a training ground for leadership team now at the USGS, which is good since they've been major partners with us both in the Arctic and in the National Water Center. This is the budget, the larger budget per portfolio. A couple of take-home messages just from here. Again, analyzed forecast support is 43% of the total budget, which is actually a fair amount smaller than what was anticipated. And that's good because we're showing a more balanced approach to actually what it takes to be mission. One of the bigger surprises was that the observation portfolio is 23%. Okay, so it does show the importance of observation, number one. Number two, how important it is that when you get it into one portfolio where the leadership team deals with all observation issues. So we'll dive into this. We have dissemination is about 7% of our portfolio, which is you're looking at close to 80, 81, 82 These are the priorities listed in, that should be 2017. That's 7.97. But these are the highest priorities within each one of the portfolio. In the observation area, there's a lot of things going on, but the fundamental is we have to be ready for the satellite launches. And we are. Okay? But there's a lot of work still going on, and that has to go on in 17 to ensure that we're ready for I can't say full utilization of the satellite data, because you're always learning as you're using it. But JPSS and those are, especially in Cosmic 2, it's also a fairly important data stream that's going to be coming at us. We have the service life extension programs for NextRads and ASOS, I'll mention those, and looking at the AutoSOC a lot more seriously now, going through the final testing phase and start consideration for what deployment would be across the United States. Central processing, the central computer upgrade has been completed, and we have the NWS merger, which is ongoing. And I point out that we don't have this successfully accomplished. It's going to be pretty hard to get a fully integrated field structure. That's an example. Analyze, forecast, support, a lot of stuff going on. New stuff like storm surge watch warning is a new product that's listed here. The National Water Model Experiment is something, and that whole build-up of the National Water Center is included in here. So, you know, I'm going to go through all of this, but you see there's a wide range of stuff happening in analyze, forecast, support. Big news on dissemination is the One National Weather Service Network. We'll go into that. Facilities, there's a relocation of departments if possible. I can tell you from a move perspective, Cleveland is still the #1 priority. We'll be moving to the new federal office building there, the Stokes office building downtown Cleveland, overlooking Lake Erie. And there are other possibilities, but I won't speak to those today. And then science and technology integration, model upgrades, galore, new experimental products, winter weather, the audit sea ice. I know the grants there are now up to 4.7 mil. It's getting there at the top where we've been historically, but there's still a lot more room. The National Blend of Models, experimental wind stream 4, trying to fill that gap in the climate weather forecast, and a space weather model, the geospace model will be implemented. This is the model developed at the University of Michigan. Big celebration with respect to the new computing capacity. Show this wherever we go. 2.8 petaflops for both the primary and backup computers. This is not hippity hop, right? This is a big increase. This is a fundamental moment for us. And now we have to make sure that it's not just today's models, but tomorrow's models. We're listing here are the immediate upgrades. We're also looking at the next generation global prediction system, which feeds into part of that increase in grants that you saw on the last slide. The big upgrades that are coming at us, let's say by the June, early July timeframe, the global forecast system will have 4-dimensional data simulation for the first time ever. Based on the ensemble common filter approach. The high resolution rapid refresh version 2.0 will be upgraded, and we'll have that upgrade in as well, and we'll start the process for the ensemble version of that. The HWRF will be upgraded with a storm surge, and as part of the operational aspect, there'll be the waves. So the wave will be directly linked to the HWRF for the first time, and the experimental connection with storm surge is something that we're mapping as well. And then the water model, this is deploying the National Water Model version 1.0 on our operational computer. This is the HWRF from NCAR. It's the community model that will be operationalized this year. The European Center's already got their new computer in, bouncing up above 2.8. Nobody's expecting them to stand still.
with respect to the dissemination network upgrade, right now, what we have as a basis for our operations is on these regional networks that were put together, all basically are different enough to cause problems when you have the November 2014 outbreak. Basically can't handle the capacity of the user demand during the extreme events. And through the Kano says you don't have big pipes, so you have a big data flow. So you jam it up and it starts impacting weather. We want to go to this National Weather Service, one National Weather Service network. What this looks like is we're basically going to operate the network the way we operate our primary and backup systems. And it'll be monitored, be implemented, monitored, managed out of NCO. The same way they do it this year. We are at 99.96 or something like that. Reliability, obviously, there's no goals we set for that one. We already are running, we have the first site is in College Park, as part of that data center. And you see the list of functions that are already operational on that system. So NATIS, for those who are really interested in NATIS, whether you're in the optimization portfolio or dissemination, it's there already. Okay? We're already building up on it. So the aircraft data, it's not just the surface mesonet kind of thing anymore. We actually have the aircraft data mapped into that as well. People access NATIS. MRMS, the MAD, the VLAB. There are a lot of functions. Nomads, there are a lot of people who access the ensemble forecast systems are doing it through Nomads. That's on there. We've just completed the fit up and build out of the older backup system, that building. And by September this year, there'll be 6 of these functions fully backed up. And we'll be practicing this switch between the two like we do with the supercomputer. So we'll really be in this mode by going into 17 with these systems on. We've been working to increase the dissemination capacity and eliminating single points of failure across our forecast offices, bulking up our internet access, and direct links with our external partners. The CWSUs, our co-locations with the FAA, we're still working to broaden the bandwidth of those lines so they can receive the HRR, for example, which is principally determined by aviation needs. We still don't have that going into the CWSU, so we want to fix that. The National Water Center I mentioned, so I'm just going through some of the highlights now. Initial operating capability is May 26, 2013. There's money in the budget to build up the operational capacity of that building with FTE, for example, built into the budget for the first time. So we're really asking for support on this one. We are reaching out to the research community. I mentioned this community model, which will give us, we'll go from 6,000 forecast locations to 2.7 million stream features with this model, and get stream flow out of it as well. So a tremendous step up. We're really talking about revolutionizing the water prediction program with this type of model capacity. Operations Center, which will be a tri-agency going in, FEMA, USGS, and us are already brought into this. We have been working with the NSF, this COASI, this cooperative grouping of research entities within the university community, and working this national flash flood interoperability. How do you visualize the output that you get from these models that people can relate to street level? It's one of the things that's being looked at. And then the data integration and service backup.